Let's start. Okay. Are you able to see my slide? Tommy?
Yes,
Yes,
sir.
sir.
Yes,
Yes,
sir.
sir.
Okay. Yesterday we were talking about the different type of choppers, right? Class A, class B, class C. Okay, different type of choppering. We have seen that class A, class B choppers are, if you combine these two type of chopper, then we can form a different type of chopper. Let's say in class C chopper, okay, where two class A and class B choppers are used in this class C choppers. Means combination of these two choppers. Means if it is in the class A chopper, it operates in first quadrant. In class B chopper, it operates on in a second quadrant. And these are the things. Means like there is certain improvement on the type of choppers. Means classification is based on this. So when it operates in first quadrant, what happens if it operates in second quadrant? Okay, which choppers is on and which diet is on. So all these things we have already seen in class A, class B, class C chopper. We have already seen this class, three different type of choppers, and we know that at what time it's quite important to note down this waveform. So please try to note down, try to look at this waveform so that when you to understand this different type of choppers, okay, the waveform in any type of whatever we have studied till now, let's take as a rectifier or a chopper, okay, all these waveforms are quite important. Waveform will really help you to understand the operation of that particular circuit diagram. So whatever we have learned till now, okay, like the class C choppers, two choppers, class A and class B are two choppers are combined together and formed a class C choppers. And we have seen that class D choppers, it operates in first and fourth quadrant, where the current is always positive and voltage can be positive or negative, depends on the number, depends on the duration of the turn on time, right? T on. So that we have already seen T on time is more than this. If the T on time is more, then the average output voltage will be positive. If it is less, then it will be negative. If the T on time is less than that of the total time period. So we have seen this. These two diagrams are quite important to see that average output voltage is positive in this case. In this case, T on time is more than the T off time. So where the average output voltage is positive. And in this case, average output voltage is negative, so that the T on time is less than the T off time. So this we have seen. Now we'll see the class E choppers. Class E choppers is operates on all the four quadrants. So it has a four thyristors and four diodes are placed at a different configurations. So four thyristors are used and four diodes are used in this. So in four quadrant operators, okay, this is it operates on all the four quadrant where the ch1 and ch4, the chopper ch1 and ch4s are on at the first quadrant, and second quadrant means c2 is on, and c2 and d4 is conducts. So all these are for the different quadrants. So it operates on all the four quadrants, okay. Either when it operates this, so operation part is when is a four quadrant choppers, and when the chopper one ch1 and ch4s are triggered, the output current will flow in positive directions. So ch1 and ch4 is on, so it will output current in a positive direction. So flows in positive directions, and output voltage will be equals to V naught will be equals to V. So this is in positive. It's operating in the first quadrant, right? When the chopper 1 and chopper 4 is operating, its voltage and currents are both positive if it is operating in first quadrant. So this gives the first quadrant operations. So when the chopper 1 and 4 is, if these two choppers are off, if these two choppers are off, then at this point the energy stored, whatever energy is stored in the L, drives the output current I naught through D2 and D3 in the same direction. Then the voltage will be negative. So voltage will be negative in this case. So this it means that it is operating in the fourth quadrant. In this case, D2 and D3 conducts. So it is operating in the fourth quadrant, and but the output voltage will be equals to V naught. Output voltage will be minus V, because this is negative, this is positive. In when this operates, so in C1 and C4 is operating, it is in positive. The voltage and current is positive, but in this case, the voltage is equals to output voltage will be negative. Now the chopper will operate this in fourth quadrant, which I have already shown you. And when the chopper 2 and chopper 3 are triggered, 3 and 2, if these two choppers are triggered, then the load current I not will flow in opposite directions, and output voltage will be negative. So since both these are negative, so it means that this is operating in a third quadrant. So when the chopper CH1 and CH2 and CH3 is on, so it is operating in the fourth quadrant. Both the voltage and current are negative. This is what is written here. Since the both I naught and V naught output voltage and output currents are negative, the chopper operates in the third quadrant. So see, during the CH2 and CH3 is off, so it will operate on the second quadrant. The load current I naught continues to flow in the same directions that of D1 output voltage will be equals to V naught will be equals to. So in this quadrant, the voltage will be positive, but the current will be negative. So therefore, the chopper operates in the second quadrant. V naught is positive and I naught is negative. So what are the effects of the source of load inductance? So we have to see this. What are the effects of the source inductance, of source and load inductance? So source inductance should be like, source inductance should be as small as possible to limit the transient voltage. So your source inductance should be as small as possible so that it will limit the transient voltage. Also, source inductance may cause the commutation problem for the choppers. So if there is a high source inductance, then it might cause the problem of commutations problem for the chopper. Usually the input filter is used to overcome the problem in source inductance. Yesterday, okay, the input filters mean what it is using. It's using a capacitor, right? To filter, input filter is used to overcome the problem of source inductance. So because of this problem, because of the source inductance problem, the filters are used. It means the capacitors are used in this case. Yesterday, I think one of you are asking about this, why we use the capacitors. The capacitors has a two functions. Yesterday I told you that when it generates the harmonics, or when it generates the signal inside the circuit, okay, it's when the circuit means the components start operating, okay, it generates some kind of signals, it produces some kind of signals. Just to remove that signals, or it can be signals, can be external, it can be internal signals. So just to remove that signal, one application of this is capacitor is to remove the unwanted signal or the harmonic. Other one is that the capacitor can be used as a storage device. Means it can charge when the circuit is charging, in a charging circuit, okay, it will store the electrical energy so that the output voltage can be continuous. When the circuit is switched off, then the load means output voltage, chopper's output voltage can be kept constant. Means the load voltage can be kept constant. Means that it can discharge. So it sometimes it looks it's something like a temporary type of battery, so that it also works as like a temporary type of battery. Means like it charges during the when the circuit is conducting, and it discharges when, so that the load voltage can be kept continuous flow of the load voltage at the load. So means that it will maintain the continuous output voltage in this case. So these are the two applications of using a capacitors. One is to remove the unwanted signal, whatever the signals are generated, because in DC what is happening that we are changing the fixed DC output voltage, fixed DC input voltage to a variable DC voltage. So the means that we need to use these filters in some cases. So filters are used, especially these filters are used in case of a step of choppers, most of the time in step of choppers, because the output voltage has to be in some cases. So this will really help to increase the output voltage also. The capacitor will also help to improve the output voltage, it means increase the output voltage. So these are the two applications of, means that the use of the capacitors in case of a chopper. So the load ripples current is inversely proportional to the load inductance chopping frequency. Means that the ripple currents are inversely proportional to the load induction as well as to the chopping frequency and peak. So peak load current, it will depend on the load inductance, and also it is used to like limit the load ripple current. and it will smoothen the inductor in connected in series with the load. There will be a ripple current. So this is a means these things, okay, there is this is a small problem. Okay, we have already done these problems. The derivation part we have already done, just to make you just to refresh back, okay, whatever we have learned in the previous slide. Okay, so this is small problems that for the first quadrant chopper shown in the figure, okay, the first quadrant chopper, we have already done this. We have to express the following variables as a function of V, R, and a duty cycle. So you have to find out the average output voltage and current, output current at the instant of commutations, and average and RMS of a freewheeling diode current, RMS value of the output voltage, and RMS and average thyristor current. So these things we have already done. Okay, that this is the first quadrant choppers. Where first quadrant choppers are used. So how do you find out the average current output, average output voltage? So we know that the duty cycle is T1 divided by T. So we can find out TV. So all these things we have already. So you just go through this. Okay, these things we have already done in the previous class. The freewheeling diode will never conduct in a resistive load. So these are the things. Okay, we can find out the RMS value from this. It's just the derivations, whatever we have done. I think impulse computations. So we can find out the average and RMS of freewheeling diode currents. RMS freewheeling diode currents are 0. So we can output RMS voltage will be equals to root of 1 by T. So we can integrate between 0 to T on. So we can find out with this, and we know that duty cycle equals to T on divided by T. So I think I'll stop here today. I need we'll talk about this impulse commutator chopper in next class, and next class we'll do this derivation also. How do you do the derivations? Can I put it in the PPT, or can we do it by sharing the screen?
PPT, no, sir. We can
Sir, can this write in a PPT,
Paper?
no, sir? We can easily learn through PPT, no, sir. Sir can explain on PPT, then while we refer to PPT, then we can scroll and learn, no, sir.
There are problems so that we can discuss, right?
Yes, sir.
Okay, then I'll make it in a PPT form so that we can discuss in the next class. Or can we do the screen mirroring and solve in the paper? Is it?
PPT is better, so later we can refer also, no, sir.
What I'm thinking is, if it is possible, okay, I'll make a PPT. So even we can do it if it is possible. Okay, we will try to do it in the paper also, so that you know in how do we do this stepwise. Okay.
Okay, sir.
Okay. With this, okay, I'll stop here. So please continue. Stay at home. Okay, don't keep on roaming. I think there is some problem with, so that you should not go out and roam in the. I know you will not even get the time to go out also. Okay, please stay at home and be safe.
Yes, we're not getting time, sir.
Okay, bye.